All right, hi guys. So we're on our extra trig little mini unit here, honors mini unit. We're going to be using no calculator all class today, so you can put your calculator away. Our objectives for the day are to be able to do trig problems of 30, 60, and 45-degree angles with no calculator. And we're going to be able to do special right triangles with rationalize the denominator with no calculator as well. So that's what we should be able to do by the end of today. First, before we get started, I want you to, as a warm-up, pause the video and try to do these rationalize the denominator questions. You can either do them on the back of your note packet, or there is a little section actually on rationalize the denominator, a little box you can do them in on like page 8 of your note packet or 9. I don't have no idea why it's in the middle of the note packet, but you can do them there or just on the back. So go ahead and pause the video and try these on your own. I'll do them up here. You should unpause and make sure you got them right afterwards. So here you should have gotten radical 2 over 2. Here you multiply both top and bottom by the same thing. You get radical 3 over 3, which then 3 divided by 3 is just 1. So this is just going to be radical 3 as our final answer. And lastly, we are going to get 4 radical 15 over 5. And that's simplest form there. 4/5 doesn't simplify, and 15 doesn't, the radical doesn't simplify. So there's a little rationalize the denominator review. Remember that we never want to leave a radical in the denominator for our final answer. Okay, so we're going to review our special right triangles. We know relationships, hopefully, from last time that if this side is x, if the two legs on the isosceles 45, 45, 90 triangle are x and x, then this side's going to be x radical 2. So to simplify things and for our calculations, we are going to make x equal 1. So we are going to say that this leg is 1, and this leg is 1, and this leg would be obviously 1 radical 2, which is just radical 2. And in our 30, 60, 90, I'm going to do the same thing. I'm going to make this short leg 1, and this is just for simplicity purposes. This is just an easy ratio to use of these triangles, because when x is 1, this is 2, and this would be radical 3. So now, when we are using these triangles, we're going to use these triangles to find the sine, cosine, and tangent of these angles. And this whole chart you are going to eventually want to memorize, because you are expected to find the sine, cosine, and tangent of these angles, these special angles, without your calculator, and you need to be able to find them very quickly. Right now in geometry, we can use our 30, 60, 90 triangles to develop them, and our 45, 45, 90 triangles. You can see where they come from. Okay, so what is the sine of 30? And again, this is no calculator. So what we're going to do is we're going to go to our 30-degree angle here, and we would be doing opposite over hypotenuse, right? SOHCAHTOA. So we're using SOHCAHTOA, but we can use them with our triangles. So the sine of 30 would be 1/2. So that one's easy. So if the sine of 30 is 1/2, I'm going to challenge you to pause the video and figure out what else has to be 1/2 then. Hopefully you're able to come up with the fact that it's cosine of 60. Why? Because sine and cosine, remember, are cofunctions. And if the sine of 30 degrees is 1/2, then that has to be the same thing as the cosine of 60, because 30 and 60 are complements. So these are probably the most used angle common angles right here, the sine of 30 and the cosine of 60. Great ones to just have memorized quick offhand. And notice cosine of 60, you can see why it's adjacent over hypotenuse would be 1 over 2. Okay, next, let's do the sine of 45 degrees. So the sine of 45 degrees, here's our theta. You could pick either one, they're both 45 degrees. Opposite over hypotenuse is going to be 1 over radical 2. Now, what's the issue with this is that we don't want to leave this in unrationalized here. So we're going to rationalize the denominator, and we end up our final answer is radical 2 over 2 for the sine of 45. So if the sine of 45 is radical 2 over 2, then that means the cosine of 45 is also going to be radical 2 over 2. These are the exact values. They're not rounded decimals. Why? Because remember, they're complements, co-functions. So sine of 45 has to equal cosine of 45. And you can see here it's going to be the same exact thing. Cosine 45 is going to be adjacent over hypotenuse, or you can look at this 45 adjacent over hypotenuse. It's 1 over radical 2. It's going to be the exact same thing. And lastly, let's do sine 60 here. Sine 60 is opposite over hypotenuse. It looks like it is radical 3 over 2. And again, there's radicals in the numerator. We're all set. That's going to be our final answer. And that's going to be the same thing as cosine of 30, since they're complements. And we can look at cosine 30 adjacent over hypotenuse radical 3 over 2, just to check it. Okay, perfect. So far, so good. If you want to pause the video and try to do tangent by yourself, go ahead. All right, tangent of 30 should be opposite over adjacent. That looks like it is 1 over radical 3, which is, we're going to just rationalize. This looks like it's radical 3 over 3. There's tangent of 30. Tangent of 45 is opposite over adjacent. Looks like it's 1 over 1, which is just 1. Tangent, remember, not a cofunction with sine and cosine, so it kind of does its own funky thing. And the last thing is tangent of 60 degrees. So tangent of 60 degrees, that's over here, is opposite over adjacent. It looks like it's going to be radical 3 over 1, which is just radical 3. So here's your chart. And again, the more you have memorized, the better. It's just quicker to have them memorized. And if you finish the lesson early, maybe you could make flashcards today if you have time for them. And when it says find the exact value, that means no rounding. So you don't want decimal approximations. So no decimal approximations. You want it in radical form. Okay. So what is the exact numerical value of the sine of 30 squared plus the sine of 60 squared? So what we'd be doing is you'd be picturing your 30, 60, 90 triangle here. If you don't have it memorized, you should keep redrawing it until you do, so you can easily draw this picture. So the sine of 30 is going to be 1 over 2, which is 1/2 squared. Plus the sine of 60 is radical 3 over 2 squared. Now when you square a fraction, you square the numerator and you square the denominator. So this would be 1/4 plus, what happens when I do radical 3 squared? That just gives you 3, because the squared and the square root undo each other, right? They're inverse operations, over 4. And what is 1/4 plus 3/4? That's 1. If you feel confident, go ahead and pause the video and try the rest of the page on your own, and then just watch and double check your answers when I'm done. Okay, the next one's still using 30, 60, 90. So tangent of 60 looks like it is radical 3 over 1, which is just radical 3. I can put it over 1 for now. And the tangent of 30 is 1 over radical 3. Now, I know that we'd have to rationalize this, but right now, I'm just going to leave it as is because it's not my final answer yet. I'm going to multiply these first. So when I multiply fractions, you multiply across the top. Radical 3 times 1 is radical 3. And you multiply across the bottom. 1 times radical 3 is radical 3. So now, see, I didn't even have to rationalize because in the end, I just end up with 1. Something divided by itself. I promise all the answers are 1. Okay. Sine of 60 we already used. That's radical 3 over 2. Cosine of 60, that's going to be adjacent from the 60-degree angle, adjacent over hypotenuse. That's going to be 1/2. And again, multiply across the top here. You get radical 3. Multiply across the denominator, you get 4. Okay, this is our first one that uses a 45-degree angle. So I'm just going to draw my 45, 45, 90. And the sine of 45 is 1 over radical 2, opposite over hypotenuse, 1 over radical 2, which you can rationalize right away. I probably will in this case, since it's addition. Cosine of 60, that's back up here. Cosine 60 adjacent over hypotenuse, that's 1/2. So since I want common denominators, I'm going to want this to be a 2 also. So I'm going to rationalize this denominator quick. And in order to add fractions, remember you need a common denominator. So now we have a common denominator, and you just add the numerators, 1 plus radical 2. I'm just throwing that out in front. That's how you normally see it. And then you keep that common denominator. This is your final answer there. That one's a little funky. Okay, sine of 60. I'm just going to redraw my 30, 60, 90 here. It's good practice. And all right, so sine 60 is radical 3 over 2, opposite over hypotenuse, plus the tangent of 45. Draw your 45, 45, 90. And that one is going to be 1 over 1. Cosine 60 is 1/2. Okay, so now I need common denominators. I'm going to make this 2 over 2. So now I have radical 3 over 2 plus 2 over 2 plus 1 over 2. So I really have a 3 plus radical 3 all over 2. Add the numerators, and then keep the common denominator. Okay, let's see what's going on here. B is 45 degrees. C is 30 degrees. AB is 8. Find an exact value for AC. Notice this is not a 30, 60, 90. We actually have 75 degrees so far, right? So to agree that this guy would be 105. So what you're going to have to do here is you have to use law of sines, except it's going to be non-calculator. Oh, that's awesome. So it's going to be sine 45 over x equals sine 30 over 8. The reason that we can do this non-calculator is because we know what these are. So I'm going to replace those with sine 45 degrees is opposite over hypotenuse, 1 over radical 2 over x equals sine 30, opposite over hypotenuse, is 1/2 over 8. So now let's cross multiply. You get I'll write it out first. 2 times 8 equals on the other 1/2 times x. So this is just 8 over radical 2, because that's 8 over 1, multiply numerator, multiply denominator. So to undo the 1/2, I'm going to multiply both sides by 2. And then you're going to get 16 over radical 2 equals x. So now we just have to rationalize. 16 radical 2 over 2 is x, which means x. All right, that's good stuff. Okay, we're going to do more of this, like this page next time. This is my favorite stuff, this page. It's so cool. Again, make flashcards if you have time at the end of the lesson. But you guys are working on pages 6 through 11 now, and you're using your answer keys at your tables to check. So good luck finishing the day. Bye, guys.